let's go over how to solve number 8 from the target round. So the figure below has 4 lines of symmetry, and it's composed of a concave octagon with side lengths all of length 13 and a circular hole with radius 4. All right, so now in addition, the longest distance between any two vertices of the octagon is 34. To the nearest whole number, what is the area of the shaded region? So let's make use of the information that we're given. So we know that each of the sides of the octagon is 13, and the distance from the longest distance between two vertices is 34. So let's make use of the fact that we know that there's 4 lines of symmetry. So we know that if we draw these lines connecting every other vertice, we know that we'll have a square in the center, and each of these lines of symmetry will cut the triangle in half. So let's say that this half of the side square length is x, and so that would mean that the length of the side length of the entire square would be 2x. And then let's say that the height here is y. So then we have a right triangle here where both the legs are x and y, and the hypotenuse is 13. So we can apply the Pythagorean theorem to say that x squared plus y squared is equal to 13 squared, and 13 squared is 169. And now let's try to create an equation to find that the length between two opposite sides of the octagon is 34. So we know that to get from that length, we have 2 y's, so y plus y, and this side length, the square, would be 2x. So we know that 2x plus 2y is equal to 34. And so now we can try to solve what x and y are. And after that, we can find the area of the octagon by finding the area of the inner square and then the 4 triangles, and then finally subtracting out the circular hole. Okay, so now let's try solving this. So we know that 2x plus 2y is equal to 34. We know that x plus y is equal to 17. And let's try squaring this equation. And we get that x squared plus y squared plus 2xy is equal to 289. And now we can subtract this equation from the first equation to get that 2xy is equal to 120. So that would mean that xy is equal to 60. So we found that xy has to be 60 for after finding the difference between the first and the last equation that we wrote. So two numbers that add up to 17 and multiply to 60, that would be 5 and 12. Now, to determine which of x and y is 5 and which is 12, let's make use of the fact that we know that this octagon is concave. So that would mean that x has to be less than y, since if it was greater than y, we would have a convex octagon. All right, so we know that x is equal to 5 and y is equal to 12. Now let's try to find the area of this octagon. So we can find the area of the inside square. The area of the square on the inside is 100, since the side length is 10. And then the area of each of these triangles would be 1/2 base times height. So our base is 10 and our height is 12. So the area would be 60, and we have 4 of those. So that would make our total area of the entire octagon 100 plus 240, which is 340. And now let's subtract off the area of the circle on the inside. So we can use pi times radius squared, which would be 16 pi. So that would mean that the shaded region is 340 minus 16 pi, and 16 pi is to the nearest whole number, that's 50. So our answer would be 290. All right, so that's how we'd solve this problem. We'd break it up into shapes that we can more easily calculate and calculate the side lengths to find the area. All right, that's what we have.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.